So we're starting on page 448. Page 448, please. Okay? Today we're going to look at two more quadrilaterals. I told you guys, right, on day one of this new unit, we started looking at polygons, right? We learned all the names of all the different polygons up to like 12 sides, right? We learned that we could have concave and convex polygons, right? We could have equilateral, equiangular, regular polygons. We could find the interior angle sum of a polygon, right? We know triangles, they always add to 180. Quadrilaterals, their interior angle sum always adds up to 360 degrees. And then any other shape, we take the number of sides and do what? Number of sides minus 2 times 180. That gives us the total interior angle sum. Well, that gives you the sum. That's all, you're done then, okay? That was that one day. Then on Tuesday, we focused in on just parallelograms. We started talking about just quadrilaterals, and today we're going to talk about more quadrilaterals. And they're going to be even more specific, okay? So, if you look at the top of page 448, we're going to talk about rectangles first. All right? Rectangles are a shape that you guys have known, for a long time. Now, if a quadrilateral is a rectangle, it's a parallelogram, right? Because what is a parallelogram by definition? The opposite sides are what? They are parallel, but also as a property, they are going to be congruent, right? Isn't that true for a rectangle? Yes. Doesn't a rectangle have opposite sides congruent? Therefore, it's also a parallelogram. Okay, a rectangle, you can think of it as just a special type of parallelogram. Okay? What's that? Yes, yes. And also, as a result, a property of rectangles is that its diagonals are congruent, right? And it kind of makes sense. I mean, here, if you just look at this picture, there's a rectangle, right? The diagonals look like they should be congruent because they are, okay? Parallelogram, diagonals are not congruent. Diagonals just bisect each other, but in a rectangle, diagonals are congruent. Okay? So, let's kind of go down here, all right? Because that's the one property that for rectangles that we need to learn. The diagonals are congruent in a rectangle. Boom, that's it, okay? And also, it's equiangular. All the angles are right angles there. But again, you guys know that because you've seen rectangles since, way long ago. So, number 5 here, let's take a look. We got some problems to do, all right? It says AD is 7.5. So I'm going to go ahead and mark that in here, 7.5. DC, okay, is 10. It wants us to find DB, this diagonal here. Now, how can we find that length of that diagonal DB using the fact that AD is 7.5 and DC is 10? Any ideas here? Yeah, you gave?
Can we put 7.5 on the other end?
Okay, so BC will also be 7.5. Very good. That's true. So, but again, though, how are we going to be able to find that DB is that length? Or how can you find that length of DB? Ideas? Yes, Julio, you're exactly right. Why can we use Pythagorean theorem here? What kind of shape do we have inside this rectangle, Julio? Yeah, we have a right triangle. Look at that, right there. Right triangle, right? Angle C is a right angle, and then BD, the diagonal, is the hypotenuse. And so, sorry.
What about the other triangle?
Well, there's another triangle in there, but since we're asked to find DB, we want to use this triangle right here.
Yeah, but why don't you use the other triangle?
Oh, like this one right here?
Yeah.
Yeah, we could use that one too. Sure.
All right. Can you
Because,
put a 10 on the other side?
yep, this side's 10. Exactly. So you could use that triangle, either one. But so the setup then, Julio, since you said Pythagorean theorem, what would our setup be? What squared plus what squared equals what squared? What would it be?
7.5.
7.5 squared plus 10 squared equals like c squared or x squared or whatever you want to say there. So I'll say x squared just so that way it's unknown. Okay? But you are exactly right. So let's go ahead and square that. So 7.5 squared is 56.25. 10 squared is 100. So then that's, well, I run out of space. So 156.25 is equal to x squared. And we square root both sides. And wow, it came out to just 12.5. That's really nice. 12.5. Okay? So dB has to be 12.5. So if DB is 12.5, what else must be 12.5? AC must be also in the picture, using this given information. Right, but then don't forget you got to square root both sides, because it was x squared equals 156.25. I need to square root. Okay? So, in this situation, since we found DB to be 12.5, AC would also be 12.5. Okay? Now let's move on to number 6. Number 6 is slightly different. Okay, so we have to kind of like eliminate these numbers now, because this is for number 6. 6 says that AB is now 17, BC is now 12.75. And I want to find DB. Okay, I want to find DB. So again, if we want to find the diagonal, how can we set that up? It's the Pythagorean theorem all over again, right? Again, because this is a rectangle, I know this side will also be 12.75. I know this side will also be 17, right? Opposite sides in a rectangle are congruent because it's a parallelogram, and opposite sides in a parallelogram are also congruent. And so let me just say 12.75 squared plus 17 squared. I would leave that, since 12.5 worked out so nice, I would...
No. When you do 12.75 squared, it's 162.565. Like, can you just do 0.6?
I would try to keep it exact. I would not round until the very end, Kava, if you can. Okay, I know it's kind of a hassle to write out those decimals. I don't think our decimals will ever go out like quite that. I mean, you don't have to worry about that for like the future, but for now, let's keep it, because I think it's going to work out nice. I think. Okay, 17 squared is 289. We add those two things together. I get 451.5625. Oh, and it does work out nice, Zaria? Great. So square root both sides. And I'm sorry, what did you say it was, Zaria?
21.25.
21.25. Beautiful. That's great. Yeah, I see if we had rounded that, and it wouldn't have worked out so nice then. So it's good that we did. So again, in this case, with this information, DB is 21.25. So what else will be 21.25? AC. Must be, right? The diagonals are congruent, okay? So that's it. That's rectangles, okay? Rectangles have all the properties of parallelograms. So, rectangles, are their opposite sides congruent? Yes. Are the opposite angles congruent? Yes. Do the diagonals in a rectangle bisect each other? Yes, because it's a parallelogram still. And then in addition to all three of those properties which come from parallelograms, in addition to that, we also have the diagonals in a rectangle are equal. Are the diagonals in a parallelogram equal? No, not necessarily. Right? If that parallelogram is a rectangle, the diagonals will be equal. If the parallelogram is not a rectangle, the diagonals will not be equal. Okay? So that's not a property there. Did you get that? Okay. You all done there, Jordan? Okay. All right, so let's look at the next shape. Okay? This next one here, you guys maybe are a little bit less familiar with, right? Because it just doesn't show up. It doesn't make a nice block, right? Rectangles make nice blocks. Rhombuses do not. Okay? So you probably didn't play with rhombuses when you were a kid, but there they are. Okay? So a rhombus is another quadrilateral that's like a parallelogram. In fact, a rhombus is a parallelogram. If a quadrilateral is a rhombus, then it is a parallelogram. Why? Well, what makes a rhombus a rhombus? What do you see here? All the sides are equal. Therefore, we can call it equilateral. That's right. Okay? Since all the sides are equal, that means opposite sides are congruent, which then makes it a parallelogram, right? So a rhombus is a parallelogram. Okay? If a parallelogram is a rhombus, so if we have a rhombus, its diagonals are perpendicular. Perpendicular means they meet at what kind of angle? A right angle, right? Perpendicular. So you can kind of see that here too. If I were to draw the diagonal, if I were to draw that diagonal, well actually you can see it right down there, they're drawn in. You can see, oh yeah, clearly that looks like a right angle that they're connecting at. And then finally, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So this diagonal here, it cuts this angle into two equal angles, and this diagonal also cuts these two angles in half into two equal, and that cuts that into two equal angles. That's two equal angles right there too. Okay? So a few more properties there, but again, that's a rhombus. But you kind of see it in the picture, right? It's very clear. Oh yeah, the diagonals look like they're going to bisect each other. Oh yeah, it looks like the angles are equal. Okay? Does it look like if we go back here, does it look like the diagonals in a rectangle bisect each other? Okay. Does it look like the diagonals in a rectangle bisect? For example, angle B here, does that look like it's being bisected? It kind of does, but not exactly, right? It looks like it's like this angle's a little bit smaller than that one, okay? So the diagonals in a rectangle do not bisect. They're opposite angles there. That is for you right now. You got your... That's right, you're fired, man. Sorry to let you go. Okay? Yeah, if you want to go now, that's fine. All right, so let's use these properties of the rhombus then to find measures. So yeah, we turn to the next page there, page 450. Page 450. Okay? Well. So we got a rhombus. All right, letter A asks us to find x, y. We want to find this length. We have no information about x, y, yet they still want us to find it.
You can't put 6 in.
Ah, yes. Why can we say that, Jaden? Okay, they look the same. And what makes a rhombus a rhombus? All the sides are equal. And so, also, since it's a parallelogram, opposite sides are going to be equal. So this is 6m minus 12. What other label could I have given to yx, though, besides 6m minus 12? What other label could I have given? Yeah, 4m plus 12. Which means, then, 6m minus 12 has to equal what?
4.
Yep. 6m minus 12 has to equal 4m plus 4. In a rhombus, this is a rhombus, we're told, use rhombus. The rhombus sides are all congruent. So we can set those two things equal.
So like all of the sides like are the same, even though they don't look like them.
And yeah, you're right. Maybe like, but they, in fact, I think if you actually got a ruler out, I bet you would see that they do actually have the same measure. They actually drew this pretty accurately, I think. But it's hard because they're slanted to see that. So anyway, now we have this equation. We'll subtract 4m from each side. Okay, I got 2m minus 12 equals 4. We'll add 12 to each side. So 2m equals 16, and then m divided by 2. I'm going to run out of space, so I'll just write it. M is 8. Is our answer 8? No. Very good. Right, Zaria. We are trying to find xy. We are not trying to find m. Why do we find m? Well, we need m to find xy. xy is 6 times m minus 12. So we'll do 6 times 8 minus 12. 6 times 8, 48, minus 12, 36. Okay, so xy is 36. Okay. So since xy is 36, what's vy?
36.
What's vw? What's wx? They're all 36, that's right.
36.
Vx? Ah, good question. We'll get to that. Okay. Actually, I think we don't get to those. We can't use that side. We can't use the sides to solve for it or anything like that. Yeah, it's a diagonal, exactly. So, all right. Next one. Part B says find angle YVW. So here's YVW. Okay. Now looks here. YVW is this big angle. We're told all we have here is that ZVW is 9n plus 4 degrees. So YVW is the full angle there, and all we're given is ZVW is 9n plus 4 degrees. We need to know what that n is, don't we? But we don't have any measure there. Do we see n anywhere else? Yeah, we got n right here, and that's for this angle. What does this angle have to be? Well, this angle has to be a right angle, because what happens in a rhombus where the two diagonals bisect each other, they do bisect each other. When the two diagonals intersect, what type of angle do they form? They form vertical angles, but it's also a right angle here. It's a right angle because a rhombus, the diagonals in a rhombus make right angles, right? These are all right angles right in here. And so that means this angle, 3n squared minus 0.75, is equal to what? 90. Okay, so this is kind of weird, but we're going to do this. We're going to say 3n squared minus 0.75 equals 90.
I don't know how to do this.
You don't know how to solve this one?
I don't think I know how to do this at all.
So, what's with the n that we need to get rid of here, Kyle?
Huh?
How would we start
Square
solving
root.
this? Okay, well, we're going to square root. That's the last step we'll do.
Okay.
So what's... Yeah, well, not subtract it. We're going to add 0.75, yep, to both sides. But yeah, you're right. We're going to get rid of it. So we'll add 0.75 to both sides. Ugh, this is hard to write where I'm writing it here. We get 3n squared equals 90.75. And now what should we do to both sides? Not square root just yet. We divide by 3 first, and then we'll get to that. Yep, divide by 3 first. We have to get rid of the 3 in front of the n squared. 30.25, yep, that sounds good to me. And then now finally, what do we do? Square root. And get n is 5.5. Very nice number. Okay. Okay. So we got n is 5.5. Is that our final answer?
No.
Yeah, no, not quite. We can plug the 5.5 in here for the 9n plus 4, so it'll be 9 times 5.5 plus 4. Oh, sorry, I kind of... There, can we see that okay?
Where did you get 3n squared minus 5a?
Okay. Where did I get this from?
Yeah, like I know it says it right there on your paper, but like, why are we solving?
So, remember, our really big picture here that we're trying to do, EK, is we want to find the angle YVW. YVW, that's this big angle right here. Only thing we know about YVW is that this piece is 9n plus 4 degrees, but we have no idea what the actual measure is, so we can't really use that 9n plus 4 to like solve for anything right now.
So why wouldn't you equal that measure
Shh, Ramel. Sorry?
Why wouldn't you equal that measure to x?
Like this one down here? What do you mean by x's? Oh, like this angle right here?
Yeah, I don't understand, like, if you're trying to find YVW, like the angle of YVW,
Right.
then why are you solving for angle V?
Because, I'll explain. So, again, you understand that solving for YVW, we don't have enough information to do anything with this 9n plus 4. We don't know what this angle is, we don't know what this angle is, we don't know what this one is, we have no information. But, here at the center, where the diagonals intersect, because it's a rhombus, these are all right angles. Why is that helpful? Because we have another place where we see an n. This has n, this has n. So if I can set this one up, set it equal to the 90,
90 from where?
this angle right here is a 90-degree angle.
Is there an easy way to tell?
This is just knowing your properties. The diagonals, when they intersect in a rhombus, they create a 90-degree angle. You can kind of see it in the picture, too. I mean, it looks like a 90-degree angle right there. Okay, that kind of helps you.
Like, where you're getting the angle measurement from, Z has like 4 angle measurements.
Yes, and they're all 90. They're all 90. All the diagonals intersect at 90-degree angles. So that's 90, that's 90, that's 90, that's 90, because 90 plus 90 plus 90 plus 90, that's 360. They're all equal. They're all 90.
So, like, I get that, but, like, how come equaling that one measurement to 90, how can that get you the angle measurement of YVW? Like, that...
I'm going to show you right now. So you believe me at least that 3n squared minus 0.75 is 90, and that n is then 5.5. You're okay with that?
Yeah, but it doesn't
Okay.
really have any relevance.
Right, so, but now we go back up to here. I see the exact same n that I just solved for, 5.5, is right there. So now I can do 9 times 5.5 plus 4.
So you're solving for n.
We had to get to n, yeah, that was the key.
Okay, so it's not like you're just, like, equaling together.
Yeah, no, I'm just not making like random things up. The whole goal there was to get that this angle now, this angle is 53.5. Okay, okay, so that's 53.5. So, if this angle is, gentlemen, listen up please. If this angle is 53.5, what does that mean this angle has to be? Also 53.5, because in a rhombus, the diagonals bisect the angle that they intersect here. So this diagonal cuts this angle into 2 equal parts. So this is also 53.5.
Does that make Y and W 53.5?
Like these angles right here?
Yeah.
Well, we can get to that in a second here, but let's just focus on answering the question. So now we know YVW is equal to 53.5 plus 53.5. 107 degrees. So the full angle there, YVW, is 107 degrees. Okay? That one was a very involved problem there, but that's what we can do. That's what we can use in those properties. We can do that. So right, so let me review that one real quick because that one was a lot of steps. Just real quick, okay? YVW is what we were trying to find. This big angle right here, okay, in our rhombus. We don't know enough information to find YVW just yet. All we know is that this angle right here is 9n plus 4, which means this angle would also be 9n plus 4, but that's it. The only other place we see an n is right here. It's where the two diagonals intersect, and we know that in a rhombus, the diagonals intersect to make a right angle. So right there, it's a right angle, so this has to equal 90. So that's why we set that equal to 90. Solve for n. Once we add n, we can plug it in up here. 9 times 5.5 plus 4, 53.5. That means this angle is also 53.5, and so the full angle is these two pieces added together. 53.5 plus 53.5. Yes?
So you think like what you would do is you would just put 9n plus 4 to equal it to itself if you're trying to find v.
That's true, but the problem when you do that, you get 0 equals 0. It all cancels out. Because you're setting something equal to itself.
Yeah, but like that's how we would solve an angle for any other problem. Why is rhombus different?
Well, so that's what this is not wrong, EK, but you're right. But the thing is, it's not helpful. This is correct. They should be equal to each other, right? This angle and this angle should be equal. That's what a rhombus property is. But in this case, that property is not helpful because you're going to end up with 0 equals 0.
Just in this case, or
In this case. No, not in any rhombus case. This is a true statement. So you may absolutely use this. In this particular case, with the information we're given, it's not helpful. That's all. Okay? All right, so this then leads to our final quadrilateral that we need to know about, and that is the square. Okay? So what's special about a square? Equilateral and equiangular, which means we call it what? Regular. Regular. This is a regular quadrilateral. It is a square a parallelogram? Is a square a parallelogram? Yes. Is a square a rectangle? Yes. Is a square a rhombus? Yes. Okay, a square is all of those things. So that means it has all of the properties. So because a square is a parallelogram, that means it's got opposite sides congruent, opposite angles congruent, and the diagonals bisect each other. Because it's a rectangle, the diagonals are equal. Because it's a rhombus, the diagonals meet at a right angle, and the diagonals cut the their angles in half. Okay, bisect their angles. So that leads us to this really kind of interesting little Venn diagram right here, where you have like the quadrilaterals, okay, and then inside the quadrilaterals you have like a set of parallelograms. And then inside the parallelograms are the rectangles, but inside the parallelograms are also the rhombuses. And then where some rectangles overlap with the rhombuses, you get the square. Okay, so the square is both a rectangle, a rhombus, a parallelogram, and a quadrilateral because it's inside all those pieces. A rectangle is both a parallelogram and a quadrilateral, and a rhombus is both a parallelogram and a quadrilateral. Okay? So, let's turn the page here. All right. And just to make sure we're kind of feeling okay with some of this stuff, I want us to try just some classwork real quick, and then I'll give you guys your homework assignment. Okay? So let's try number 2. Okay, and then also try number 9, please. Okay, so 2 and 9. Give those a shot real quick. Just make sure you got it down. So 2 on page 452. And then 9 on page 454. This is not the homework. This is a classwork. Real quick, I just want to make sure we're okay with these. We're feeling okay. So 2 on page 452, and then number 9 on page 454. Okay, just try those real quick.
Wait, what pages?
I'll put them up on the board.
So you're taking 18 and adding it to
BD? Or is it asking for
Yeah, you're going to find the sum. Now, you can use your properties of rectangles to help you, right? So remember, for example, that in a rectangle, what's true about the diagonals? The diagonals are going to be equal. They're the same length. And so once you find AC, you know BD, and so you can just, use that to help.
I don't know what you would do.
Yeah, you can decide you
But like what triangle? What triangle?
You can kind of use whatever triangle you want, as long as you can find A plus BD.
This is where my I
I
need
didn't
help.
use that because like for like if you look at this triangle, there's no hypotenuse.
Oh, right. Don't put that triangle, yeah.
And if you look at this triangle, there's no hypotenuse.
You're right. So you're right. You can't be any triangle there. Because you want to use the right triangle, right?
Is there flex tomorrow?
But like how do you
No, flex on that.
how do you do that if you
There's
don't
no
know
flex
this
tomorrow.
triangle?
No, there's flex tomorrow. But then all next week.
Yeah, but like that's two triangles.
So what, I need to do that.
If you want to do that together, it also makes one big triangle.
So you would do
This is where my
Just help. Yep.
I don't know how to do this.
Did you label your picture?
No, I don't know what to.
So label it. That's good. And then you did. Oh, you did both, 2 and 3, okay.
Yeah.
So once you found, be careful though, it asks for the value of AC plus BD. I think you found just one. But here's the thing though, right? Okay, but here's the thing. In a rectangle, the diagonals are the same length, aren't they? So, if you found one diagonal, what's the other diagonals measure? The same thing. So, let me get Kyle going here, okay? Okay, that's right. So then, set up, look at your paper. All right, so you got a rectangle here, and then look, you have a right triangle right in there, right? So find that diagonal. Use right triangle stuff to help you find that diagonal there. Okay? So that's one length. So what is it? So what did you find? BC or AB? Or AC or AC? So what's BD got to be then?
well, if I'm doing this one.
Right? So that's 35. So what does that mean? AC is 35. What does BD have to be?
Yeah, but what's are you using this triangle?
You can.
It's the same.
I can't play flex, so I don't know where we're going to do it. Let's do it sometime.
It's the same. So you would just
Exactly right. Okay. So which 35 is the measure of AC or BD? Which one did you find? You don't remember? And that's okay. Okay. Just BD?
Yeah.
So in a rectangle, the diagonals are the same length. So BD is 35. In this case, that means that AC will also be 35. So if you're trying to find AC plus BD, what are you going to add together? Mel, time to go to your seat. Thank you. 7.
What?
So that just be my answer?
That's yeah. For some reason, they want to find stuff. I don't know why.
Hey, whatever. It's all good.
Page 454, number 9, guys, as well. Okay, so what I'm showing you is the one. So what you will find on the side.
And then that would be my answer.
That would be
I want to bail. But I could also plug it in this.
Yeah, that's right. Same thing.
So I got 77, and I did BC is 40, and then for that, I got 50, so I wanted to 50 minus 40.
Okay, sorry, hang on. I got it here. I think that's right. I think, but it actually could be 40 minus 50.
Yeah.
Which would be a negative 10, actually.
I
So
didn't-
weird.
Is this right?
Yeah, I didn't want to break it.
No, I think
Is this right?
Length and stuff, but I think in that case. Yes, that's right. Good job.
Alright, do we have to do number 3?
Jason and Ramel. Have a seat, please.
Do you have to do number 3?
I'm finished, Mr. Witt. What? No, we gave them, but in this case, it turned out.
Wait, can I read your shirt?
I don't even know who the name is. Mr. Whittemire?
What's that?
Help me with the...
We're going to go over because it has fractions, and I didn't realize that. I apologize. Okay. Eyes up front, folks. Here we go, real quick. Okay. These problems kind of annoy me, guys, and I mean, you guys probably think all these problems are annoying because it's just math, and I get that. But what I mean is, they're kind of silly because they're like making things needlessly difficult, I think. But anyway, all right, AB 21, AD 28, okay? To find the value of AC plus BD, it means I have to find what BD's length is and what AC's length is. Okay, so using what we know about rectangles and also what we know about like right triangles and things, can I get a volunteer here? How can I find, for example, BD's length? All right, how can I find BD's length? So yeah, Zaria, go ahead. 21 squared plus 28 squared, yep, equals x squared. Folks, we have a right triangle right here, all right? I know we're not in the right triangles unit, but guess what? We got to be able to use that stuff from previous units, right? So we get all that there. I'm going to go ahead and add up 21 squared plus 28 squared, and that gives me 1,225. And you square root both sides and get x equals 35. Now, that means this diagonal here is 35. Okay? What kind of shape are we dealing with in this picture? It's a rectangle, right? Well, it looks like a square, but we've got to be careful. The directions say find the lengths using rectangle ABCD. And it looks, you know, so this is a rectangle for sure. It could be a square, but we're not given enough information to determine that, so we're just going to assume rectangle. Okay? Squares would need to have equal, you know, all the sides are congruent. Since it's a rectangle, the diagonals of a rectangle are what? The same. So if BD is 35, what is AC?
35.
35. So AC, it's 70, that's right.
0.0. Yeah, right.
Sure, 0.0. Okay? Alright, let's skip on then. So that's 70. And again, why they have us add AC plus BD? I don't know. It's kind of silly, but again, there it is. Alright, they asked us to add it. We did. Okay? Yep, we're going to skip ahead. Mel's like, something good? Okay. Number 9. Number 9 tells us to find AB. Here's AB. Do we know AB is not labeled? But we could label it, very good, sorry, as 7x plus 2, or what's the other label we could give it?
4x plus 15.
Right, because this is a rhombus, all the sides are congruent. So that means this thing's either 4x plus 15 or 7x plus 2, which means to solve for x here, what's the equation we can set up?
7x plus 2 equals 4.
That's right. 7x plus 2 has to equal 4x plus 15. Okay? The two sides that are there have to be equal. So we'll subtract 4x from each side. We get 3x plus 2 equals 15. Subtract 2.
I got like 4.33.
Wow, I can't do math. I forgot to subtract 13. There you go. Okay,
Yeah,
sorry.
I got like 4.3.
And then, yeah, divide by 3, and we get a decimal. And that's really mean of them to do that to us, but that's okay. I'm going to leave it as 13 over 3, like that. Okay, I'm going to leave it as the fraction. Which, now that we have this, okay, is this our final answer?
No.
We're supposed to find AB.
Oh, yeah, so you gotta plug it in for the Y. So 12.
Ooh, for the y?
Now you plug it in for the equation.
Yeah, right into the equation there. So 7 times 13 over 3 plus 2. Okay, that's going to be our answer, and so I'll type that in. So 13 over 3 plus 2. So I get 32.3 repeating. And so I'm going to leave it as 32. I'm going to leave it as a decimal this time, and I'm just going to put the fraction, the little, not fraction bar, the bar on top to show that it repeats. Okay, guys, you shouldn't. I mean, I know that when we see fractions, we think to ourselves, you know, oh my gosh, this is not, you know, I can't be right because I got a fraction. And, you know, sometimes we do end up with fractions, all right? I'm going to make it an aim of mine that we don't end up with like fractions like that, hopefully, on our tests and things, okay? But it could happen. We need to be prepared for it. We can use calculators. We can do that, okay? So don't fret if you see a fraction. You're like, oh no, okay? Sometimes that happens. Okay? So that's AB. And since AB is 32.3, BC is 32.3, CD is going to be 32.3, and AD will also be 32.3. Okay, rhombus, all the sides are congruent.
So is that it?
So, I'm going to give you guys your assignment then, okay? So if we go back then, for the homework, I'd like you to try number 3, 4, well, I guess 5, 6, and 7. So I'll put this on the board. Is that better? That might be better. So I'm starting on page 452. Numbers 2 through 7. Okay. And 9 through 13.
9 through 13, yeah, right.
Okay.
You gotta do all this, that's a lot more.
Well, you already did number 9, you already did number 2.
I know, but like, I don't even know, how do you do number 9?
Wait, for number 9.